Welcome back to the mountain bike build series. This week, we're done welding together the main tubes of the frame, but there's a lot of details left. So we want to put on the rear brake ISO style tab that's going to hold our brake caliper, a reinforcing brace tube right here between the seat stay and the chain stay, and then a seat stay bridge between the two seat stays up here. So we got to fit those things up before we can weld them. Let's get into it. Welcome to Cobra Frames. I'm Joe. This is the shop where I build Cobra frame building tooling. And the tooling is designed to help you, the frame builder, succeed on your mission of making sick bikes efficiently and in a way that you can enjoy your process and be proud of it. But in addition to making the tools, I'm invested in helping all of my customers succeed generally, and doing the podcast that I do and doing these YouTube videos are part of that. Or send me an email, ask me a question. I'm here to help. So that's what this is all about. So we need to fit up the brake tab. You know, like there's a disc brake on the hub, and then on the frame there's a brake caliper. Right, it squeezes on the rotor, and it's held on, and there's different standards, of course. There's more recently for mountain bikes, you see post mount. For road bikes, more recently, there's Shimano's flat mount. If you go back a little while, you'll see ISO tab mount was a real popular standard through like the mid 2000s, early 2010s, and before that there was Hayes direct mount or something. Nobody's using that anymore, but it's weirdly similar to the Shimano flat mount of today. So anyhow, I'm using this standard. It's called the ISO standard. It's these holes that are 51 millimeters apart on center, and there's a specific relationship between the location of these two holes, 51 millimeters apart on center, and then the center line of your hub. And so, and then there's also this tab sits in plane with your with the wheel offset, and there's a whole spec that defines that relationship. And I'll link below a PDF if I can from Hayes, a tech document that's really helpful if you don't have this cool tool. I got this from Anvil Bikeworks like 5 years ago or something, and what this does is it slides onto your dummy axle, which I also got from Anvil Bikeworks, and it just gives you the mount points for one of these tabs. And what was really helpful with that is that it holds the stuff for you so you can weld it or braze it, but it's also really useful because then you don't need to worry about that spatial relationship. It's built into the tool. You just put the thing on, make sure that it fits right, weld it up. And so I have some tips for that. First, I got to get this on the dummy axle. So it's in place now, and it's got this handy little screw here that kind of locks the position. You swing it around, and then you grab your tab. Maybe it goes this way, and then you have these two. I think these are M6 or yeah, I think these are M6 screws. You thread these in there and clamp it on. And let me go back a little bit actually and explain the reason that I'm using this standard. You know, you wouldn't find many bikes for sale today in a local bike shop that use an ISO tab. Most of them have post mount, and post mount is maybe a little bit more convenient for the end user or a little bit more slick looking. But I think also a lot of people would argue the prevalence of post mount has to do with the dominance of aluminum and carbon fiber frames and the mass production method. And when you're making steel bikes and even titanium frames, the ISO tab actually works pretty well. It lends itself well to this process, but what it means is that then you need an extra piece of material, an aluminum adapter, and that's not the most sexy thing in the world to put on your bike, but it really makes fabrication, I think, a lot easier and simpler, and it is not a bad spec from a technical standpoint, and that's why I'm using what seems like in the general bike industry, sort of a dinosaur technology. There's a lot of frame builders who will go to bat for the ISO tab as being a good way to get the job done. Makes sense to me. From my little experience, it makes a lot of sense. Plus, I have the tool to do ISO tabs, and I don't have the one for post mount, and I'm not about to stop the project just to deal with that. So we're doing an ISO tab. I'm sure it's going to work out just fine. So these screws here will hold on your tab, And what you need to do is use a grinder and hand files or a milling machine or whatever it is to fit this up. So I have this one from Paragon Machine Works. This is machined. And then I have this one, which is like water jet cut from like Nova Cycle Supply or something. Or no, that'd be laser cut. You can see by the cut quality. And I think I might use this one actually, just because there's less contact surface area. And so it should be easier to fit up. Less metal removal than trying to get a long section of it fit up nicely against there. And I think this should be plenty strong for what I'm doing here today. Something I learned the first couple times I used this is that when you have these screws and you run the screws in by hand and then you loosen this and you kind of swing it against and you check the fit up that you have and then you go back to the drawing board and you grind some more. And when you're doing that over and over again, running these screws in and out is a pain in the butt. And so what I did, I picked up some little set screws. I think I didn't even have grub screws, so I just chopped off the heads of some other screws and I'll just thread these in part way. And I ground a little notch in there for a screwdriver in case they get stuck. I can back them out. And now this way I can just kind of press the tab. Let's see, which way does this even go? I think it goes this way. I just press the tab up against here, and then I can do all my fit up work, taking it on and off more easily. And then when I'm ready to actually do it, I'll run the screws in for real. I want to get a nice fit up along the length of it. And you can see right here I have a gap. I want to be flush. I want to be flush up against the dropout face when I go to actually weld it on. So I'm starting out here, and I'm just going to trace some little lines, make some little cuts, and just kind of guess and check on it until it fits up. And if I get a little bit loose in one spot, I can always rotate it a little bit further in by grinding more. So I'm going to try and remove the least amount necessary to get a good fit up, and then I'll weld it on. And so it's the name of the game. So I just recently bought this Metabo angle grinder. If you talk to welders who do a lot of angle grinding, they like Metabos. So I bought this one, and it's pretty sweet. It's funny, I never owned one of these. And I always thought these were kind of crude for the detail-oriented work that you do in frame building. You can get good with these if you do a lot, and you get, it's like a tool. You need to learn how to use it. And here, I'm really roughing a lot of material out, so I don't want to start with a hand file. I don't have a vertical bandsaw to lop a bunch off, so I'm going to start with this. I'm going to try and establish an angle, something like this, not like that, or I'm going to try and come in at about a 45, and I'm going to work up to that line. And the first pass is really rough. I think I can do most of the roughing with this thin cutoff disc, and then I might dress it up a little bit with more detail-oriented tools if I need to at the end. We'll see how I like this process. Yeah, right away it just eats through a whole bunch of material. You can just slice right through, and that's great for this roughing stage. Though it certainly does heat the piece up quickly. So yeah, I need to change that angle, and just taking little mental notes here. Yeah, all right. Well, I need to be careful. I might overshoot it here, but I got a backup tab or two, so if I do, that's all right. I'm learning here. Yeah, this thing is incredibly fast. You can just slice through stuff like butter. Would be really good for this, especially if you knew exactly the shape that you were looking for in the end. Here I'm kind of figuring it out as I go, so it's maybe a little dangerous way to work. Also makes a huge mess compared to like hacksaws and hand files and stuff. And the part gets really hot. It's nice to have a little cup of water you can dip it in as you're going, and then the water, of course, cools it while it's in the water, and then you pull it out of the water. The surface is wet, and there's all this evaporative cooling. The water on the surface of the part is like turning into water vapor, and that pulls a lot of heat out as it phase changes the liquid water into water vapor. I don't know, I'm maybe botching this with the... I may be having too much fun here with the angle grinder. If I had to save this piece, I maybe could, but you can see here where it contacts. You can imagine if it's like touching close to the point of rotation and bottoming out, then you remove a little bit of material and it swings quite a bit. As you start to get thin, like right in here, it's kind of thin. I maybe removed too much material there. that's harder to correct for. So since I have some other tabs around, I think I might just start over with a slightly different approach, but I'm having fun with it. It's good to have backups for this sort of thing, or to take a more slow and steady approach. So now what I have left to work with is 2 of these Paragon Machine Works tabs that are identical. I don't have any of these with the relief, and what that means is that there's just a longer area of contact that you need to fit up. So you could start by, you know, relieving a section out of the middle so you have less total area to fit up. I think what I'm going to do is I'm going to start by relieving a little bit of area off of the back that I don't think I really need, and because this is really not that helpful. You know, that's really too close to the dropout. I don't want to have to worry about that stuff, so I'm gonna kind of curve it back some, and then I might also relieve some out of there, and try and fit it up along the length of it. I'll never learn my lesson. Gets hot fast when you're cutting, but you can see I just relieved a bunch off of the backside here, and trying to make it look smooth. I'll smooth that over just a little bit more, and probably end up doing the relief out of the middle and then trying to fit up the contact areas. Yeah, before I did that relief, it would kind of hit in the corner there against the dropout in the weld, and now I don't need to worry about that, which I think is for the better. So what I do need to do is I need to establish a little bit of, mainly I think I need to start getting a bevel on here so that it fits tight against there. So I guess I'll do that first. You can see it kind of contacts on the inside of the tube, not on the center. Every time you remove some material and you put it back on, it contacts in a different way in a different spot. As you get a little bit closer, you know, it's kind of obvious, but you just always gotta incrementally sneak up on it. If you did these 10 times a day, you would know exactly the shape you were looking for in the end when you started, and you could do it in 1 or 2 tries probably. But for me, I'm trying to always conceptualize the shape that I'm going for, and you can't really see it until you're there. So, yeah. The way that the tube meets the tab, the tube is kind of going at an angle and the tab is parallel with the center line of the frame, and so I'm gonna bend the ear of this back a little bit to try and get better contact where I want it. And so I wish the tab was a little bit longer, but we'll try this and see if this works. Nice, yeah, so now this part here is kicked in a little bit toward the tube. Well, you know, I still want this mounting surface, I want that part to be flat, but this bottom part just connects it to the frame. It'll be easier to get a nice contiguous sort of fit up if it meets the tube a little bit better. So the tab fits up against a tube. The tube is of a known diameter. It has a particular angle. It's a straight tube. There isn't a taper or anything on the tube. So it's a relatively simple fit up in that way. It's just that this tab comes in at a different, it's a multi-axis angle thing. And so anyhow, if I was gonna set this up on the milling machine and miter it, I'd have to build a fixture that was kind of complicated and I think a little bit specific to this bike. But this little sanding drum here is just about exactly the diameter of that tube. And so I can use this to kind of give the half round profile here. And so now that I have this roughed in so that it's getting closer, you know, about a millimeter or so gap at the most, or maybe 2. Anyway, I can start to rough in this sort of half round profile. So up here, I'm more, I don't know, 30 degrees or something to the part, and as I get over here, it's a steeper angle, and so I'm kind of going from like on the center line of the part almost onto the side of the part, and I'm gonna start roughing in that a little bit. The material removal rate of the grinder is insane. It's just like a fire hose. It's just, it's a rocket ship. And then you have finer tools, and so part of that has to do with the grit of the grinding abrasive, and part of that has to do with, you know, this is maybe kind of worn out, but this is, you know, very much a slower material removal rate, which is good for control, but it's slow for getting anywhere. So, you know, that's just the nature of the beast. And my little grinder over there with the belt, that's useful for some stuff too, but again, it's much slower than this other one. So I think this is particularly useful as a roughing tool, and it could be pretty effective as a finishing tool if you were really good with it, and I'm not so good. So I'm gonna start sneaking up more slowly now that I'm in the ballpark. So we're really getting a lot closer now. I want it to be a good fit up just because I'm not a great welder and I don't want to have to deal with a gap, but you know, it's getting a lot closer. So similar to this first one that I passed on, that I botched up, I'm gonna relieve a section out of the middle, I think. I kind of sharpied it in. So I'll try and make it look pretty in the end. Right now it's in a very rough state, right? But I'm just trying to remove enough material so that all I have to worry about is the fit up contact right here and right here. And when it's a long piece and you want tight fit up over the whole length of it, it makes everything really tricky. But if you have shorter sections, then of course it's a little bit easier to get good contact, and there's no reason that I should need that much contact area from what I know. I'm gonna try the hand file now for a minute. Whole bunch of different tools here. The hand file is nice at kind of finding the high spots and only hitting the high spots. And so I kind of want it to look a little bit straighter, and I think this will help. By relieving the center section of this with the tools that I did earlier, it's a lot easier to get good contact over the area because you just don't need to worry about what's in the middle. You can focus on the high spots, and when you get rid of one pinch point, the whole thing swings closer. It just makes the fit up a lot easier. All the different grinding tools have different strengths and weaknesses. I'm gonna use this grinder just a little bit. I don't know if I need to, but one of the things that it has that the others don't have exactly is it's got an outside corner that comes to a point, or it can come to a point if you keep it dressed. And then also it grinds at a slower pace. The angle grinder also has, you know, you can do sharp work, but it's just, there's no control on the angle grinder unless you really have expert hands, which I don't. So. This baby is pretty well done. I could get it fitting up better, and maybe that's worth doing. I think I got it close enough that when I put it on here and I fire up the welder, I think I can weld it on securely without making things worse, without blowing holes in the tubing and stuff. The worst fit up is right up there at the tip end of it, and I would kind of like that to be tighter, but in order for that to be tighter, I'd have to do a lot more grinding, and I kind of think I can make it work. I would usually try and get it tighter, but we'll see, you know? If it blows up in my face, it's my bike, and it was a learning experiment. It's good to know how much of a corner you can cook, you know? Like, you don't want to be just careless about the quality of your work. It's important, but sometimes it's good to know where the line is, you know, like what can you get away with, and especially in production and stuff, that's important. I'm not doing production. This is like a labor of love, and I wanted to share the things that I know about frame building with all of you, but I'm curious about that. So we're trying something new here, kind of a crappy fit up. We'll see if I can manage to weld that in a way that I don't regret later. We'll see. You can see here, that was from the jaws of the adjustable wrench, left some marks on here. That's going to be in a spot on the frame where you just won't really notice it that well. And you could try and, you know, sand or polish that out. You could also try and grip that with a piece of copper in the jaws or something to keep it from marking it up. Copper is softer, and so the copper would squish and your steel would look more smooth. There's all sorts of ways around that. I'm not going to sweat this in this instance, but something to consider if you're going to go bending tabs and stuff. Before I can weld this, I want it to be all bright, shiny metal, and here we have some mill scale, so 80 grit emery cloth off of the roll. So I'm cruising this bike down the trail. It's sweet. Oh crap, I need to pull the brakes real hard. There's an emergency. And when you do that, there's all this brake force that's going into this one small area. And it's possible that you put a big bend here in the seat stay because the rotor wants to keep twisting and keep moving forward with the forward rotation of the wheel, and yet this is trying to push back against it. And so it's possible that you put a bend in here, and what's common then is to just do a little brace tube that connects the seat stay and the chain stay and just distributes the load over a larger area. It's kind of a band-aid. It's maybe not the best design you could possibly have, but it's pretty effective. It's pretty simple, and it works with the kind of brakes that I'm using. So if you look at road bikes nowadays that have flat mount brakes, those are designed specifically with a smaller caliper that fits right in here pretty well. And then the mount is down here on the chainstay. The chainstay is stronger, and then naturally the seat stay kind of braces in conjunction. And so that's the beauty of flat mount brakes. With the ISO tab, a lot of times you're gonna mount it on the seat stay, and then you're gonna run this little brace. And so this should be pretty easy for us to whip up. And the reason that it's so easy is that this is a 3/4 inch tube, this is a 5/8 inch tube. The only information I really need to know to miter this is what is the angle between these two, and then how long do I want it to be. And let's say I wanted it to be like, I don't know, 60 or however many millimeters, and then I got it all the way off from 60, I was at like 55. Well, that just moves it a little bit, right? And like that doesn't really matter that much. I just want it to be somewhere in here, and I want it to be kind of a tight fit. It shouldn't be that hard to cut this so that it does that. This is a crude tool, but it is a fast tool, and sometimes that is a lot of fun. Wow. You're working with the angle grinder, it's probably a good idea to just keep a little cup of water around so you have it already, so you don't burn yourself. Like 57 and a half. So I did some quick math based on that bevel protractor reading of the angle between the seat stay and the chain stay, so that now I'm gonna miter this. This is where it meets the chain stay with the 3/4 inch hole saw. I got on the center line of it and I used my little angle gauge to set this up. It's really not fussy work at all, and if I screw up one of these miters, I can always go back and nibble a little bit off, or I can cut another chunk and start over if I totally have to. That cut fits pretty nicely here, and now if I look, that cross line here, that was my rough mark for where to bring the cutter up to. If I bring it up to that mark, that's a pretty good spot. I could bring it even a little bit further. I think I will. I'll bring it in a little bit tighter, and my miter angle looks good to me, so I'm gonna carry on. The angle of cut shouldn't be that fussy here. This is 1/2 inch diameter tube. You can imagine, let's say you had like a teardrop shaped, mega oversized aluminum down tube on some road bike or something, and it's like this tall where it intersects the head tube. That's a huge cut, and if your angle is off by like a fraction of a degree, that'll make a big gap at the one end where it's not fitting tight. This has such a small cross section, even if you were off by like a whole degree or two, you might have an acceptable gap. So I don't think that the tolerance for like the number we're reading here is nearly as critical as in some other applications. That looks pretty good to me. This trick here where you hold the tube in a cordless drill and spin it and hold this works really well. However, most of these only have a chuck that opens up to 1/2 inch or about 13 millimeters. And so this is some of the only tubing in the frame that'll fit right inside of the chuck. Also, if you just crank down on this and tighten it up, you'll probably put a triangular lobe shape into this. The tubing is relatively thin and these have a lot of clamping leverage, but it does work well for these short little pieces. That's a nice fit there, and it's pretty positive. You know, you can rock it and then all of a sudden it kind of catches. You feel it. Some people stylistically will put a curve in these. Looks really good. You know, I kind of have more of a straight lines, angular thing going on in this frame, and so that's why I wanted to do a straight one, but certainly a curved bridge here can look really cool. And there's all different ways to bend smaller diameter tubing for those ends. Smaller diameter tubing tends to not be as difficult to bend as like this. You know, we used my bender for, really would be almost impossible to bend this with any DIY method and not have it ripple and kink. Even the 3/4 inch chain stays, 19 millimeters on those. You know, it'd still be pretty hard to get a nice smooth bend, and certainly to match them to each other is hard with a hack method. 5/8 diameter seat stays, you know, these are pretty thin. These are like 28 thousandths wall thickness or about 7/10 of a millimeter. Pretty difficult to do a smooth bend, but also difficult to match them to each other without a good bender. But when it comes to stuff like this, you can do a hack bend on this, and the wall thickness relative to its diameter, this is 0.35 wall or about 0.9 millimeter wall, 13 millimeter in diameter or 1/2 inch diameter. This is not terribly hard to bend without kinking it. And so for little decorative stuff, if you want to bend it, and the same thing is true for up here on the bridge. I'm gonna do again a straight tube here because I kind of want that straight line aesthetic for the bridge I do up here, but certainly a lot of people put a bent one in here, and it's pretty easy to just bend that around some sort of round object in your shop, and you know, there's pretty good likelihood you might be successful in getting a smooth bend. And if that doesn't work for you, bending it around an old bicycle rim or in a fork blade bender or something, it's not the best method for actual like seat stays where you want symmetry and control and precision. But for the decorative stuff, if you get a nice smooth section, you just cut a middle, you know, piece out of that, not on the start or the end of the bend, but just a middle section, and it'll look pretty good in the finished frame. Okay, so we want to get the seat stay bridge in here. If you think about traditional road bikes, and a lot of bikes, but especially road bikes, they had rim caliper brakes. And so the wheel is in here, and then there's a brace tube that goes across, and it has a brake hole mounted here, like a 1/4 inch or whatever diameter hole, and that's what you mount your rim caliper brakes on, and they squeeze against your rims, right? And then there's other brake styles, but anyway, so sometimes you call this tube a brake bridge, but nowadays everything is, even on road bikes, everything is disc brake, but especially for mountain bikes, it's been disc brake for ages. They never really had rim caliper brakes. Well, they didn't have caliper brakes, they had V brakes and cantilever brakes. Anyhow, we need to put a tube across here. I'm not gonna call it a brake bridge, I'm gonna call it a seat stay bridge. But because there's no brake here, what's the purpose of that tube? It just kind of stiffens up the rear end. If you didn't put that tube in here, it would have less rigidity, it would flex around more, and so that tube doesn't really get in the way, and it's standard practice to put it into frames. If I was interested in, like, you know, challenging conventional notions of bike design and getting to the bottom of what's the best, you know, I might try not putting it in there. I might try putting 2 of them in there. Who knows? But it works. It's what I'm used to. I'm just gonna stick with the program. I don't think there's any good reason not to put one in there. And it's a pretty easy tube to fit up when you have the tools, and I have the tools. I'd love to show you my process. So when we put the brace tube in here, do we want it lower or do we want it higher? Placement is really important. I actually welded one into a frame one time and I had to hacksaw it out and redo it because I got it wrong. If it's too low, you don't have enough tire clearance. You put it up a little bit higher, you might fit the tire, but not any room for mud or anything. You get it up too high, it's gonna look super dorky, and it doesn't, you know, really serve much of a purpose when you get it way too high. And so what's my baseline for knowing where to put it? You know, like this is a game show, and it's going, and I gotta tell it when to stop, right? So my first baseline is that I already kind of figured out the same thing down here. And if I measure just a rough measurement from the very extent here to the center line. It's reading about 388 or 389 millimeters. And so I could just do the same thing up here, and that'd be a totally acceptable way to do it. You'd know that you would match it, and if you had put the thoughtfulness you needed to into it here, then you'd just be getting the same thing. Neither one of them is going to be tighter than the other. I'm also going to model it up in BikeCAD as a check. So I modeled it up here in BikeCAD, and you know, when I pull up the same number, 388, 389 in there, as what I measured on the chainstays, you know, this is with the diameter of the wheel that I've used for everything, and it should be close to the tire that I actually put on the frame. That looks like an acceptable amount of clearance. I might actually bump that out a couple extra millimeters. It's good to have a second check, you know, check one thing against another. This is a tool that I made a couple years ago that allows you to hold the bridge in such a way that you can access both sides of the cuts, and you can do them on the milling machine in a really pretty straightforward way. This design is pretty much straightforwardly ripped off from Jeff Buchholz at Sputnik Tool. He makes and sells these. If you want one, definitely buy it from him. I was in a phase where I was thinking I just practiced making tools and was never planning to sell this to anyone, so I didn't feel bad about ripping it off, but definitely this is his idea, and it works great, and it's a really smart design. There would be different ways to derive this angle. I'm trying to do it here with my bevel protractor. Again, because the small cross section of the tube, if I'm off angular, if my angle is off by maybe a whole degree or so, it probably won't be too bad. And if I scrap the tube and get it way wrong, it's very little expense and time to do it over again. So in this case, I'm just going to measure here with the bevel protractor, 44 or 45. I think it's 45. So this tool here is great for holding the tube in a really smart way, but there's more than just holding the tube. If we just put this into our vise, we can set the angle, we can set how far, you know, where along the length of it the cutter is coming in, we can get it on center, all those things, but we want to cut both sides of it. And so what you got to do is like then take it out of the vise, switch it around, set the angle again. I've seen people actually loosen the bolts on the head of the machine and then change the angle of the head, which it kind of sounds like a good idea maybe because, oh, you can just set the angle that way. It's a very slow way to do it because to get this very straight again is a whole production, and you want this really to be quite straight to the machine. So I never change the angle of the head if I can avoid it, like ever. I'll leave it 90 to the table always, unless some like really weird reason, you know, that I really need to. And so the best way I've found to miter these is to get one of these. And this here is like an adjustable Toolmakers angle gauge, and it's a cheap one, and you can use a really cheap one, that's fine. There's degrees of adjustment here that are labeled for what angle it sits at, and then this vernier up here is actually for minutes of angle. You can subdivide a whole degree into 60 minutes, and so you can do, I think, 5 minutes of angle with this. And you know, it's not necessary for our purposes, but anyhow, this allows you, you know, with a vise stop here, I use my regular Kurt vise, and it's this always is on the machine. I don't need to set up the Kurt vise, it's here. Then I grab this piece and I loosen these two screws. I set it to 22.5. I slide it against the stop. It's positively located. I put in this piece, and now it's positively located, and I just need to use another block here just to get it so that the vise doesn't bottom out on itself. And so now the part is held tight. I can make a cut, and then I can loosen this up. I can flip the part over, and I can make another cut. And then, let's say it's too long, I might work in on it and take a couple series of cuts, but I can do the first cuts, and then if it's too long, I can do it all over again. And I'm always, I'll move the table in the x-axis here. But the beauty of that is that I move the table in the x-axis so that it's cutting a little bit shorter, and I make some more cuts, and I'm still flipping around the center line of the part. So like, let's say you started by drilling a little hole in here for a fender mount. for like a fender strut, or yeah, for like mounting a fender. And then you wanted that to stay central. Well, you could be flipping it around the center line the whole time. So let's say you do a first series of cuts and it's too long, and the second series of cuts is too long, and by the third series maybe you get it right, whatever, you're always flipping it around the center line. And so this little piece down here is the secret sauce, and then this of course is obviously useful too. This whole setup is, in my opinion, the only way to do it. I mean, of course there are other ways, but I don't think they're nearly as slick, and I really love this setup. So I got to get centered up on it, and then I can start making cuts. Let me actually step back. This is not the only way to do it. If you listen to my podcast, we talked about this directly. Carl Strong and I were talking about tools, and he said, you know, part of your experience in the shop comes when knowing when not to use a tool. So I would say this is the only way to do it, in my opinion. There's other ways to do it. This is the only way to do it if you're going to use a setup. If you're going to use a machine, and for someone like me, I don't build a lot of bikes, I would prefer to use a machine, not scrap a lot of tubing. I just kind of like having numbers and working up to stuff methodically. But if you have a half round file or a rat tail file, a round file, and a vise, you can do this really quickly by hand also and get a good result. It takes a little more experience to get a good result, but you can definitely do it, and some people do. And that's kind of the whole thing, that, you know, the more experience you get, the faster you are at little steps. It's not always worth doing it set up, but if you're gonna have a setup on a machine, I think this is the way to go. One of the real cool things about this is that you can test fit it in the frame, and then you can bring it back to the mill and cut a little bit more. And damn, that's pretty close. So I'd want to just leave it. I'm going to measure it and decide whether or not to take another cut. Yeah, I'll take that. This looks pretty good to me. I think this is going to work fine. Oh, it's our little harvest today. We got a bountiful harvest, some nice, lovely, nice little parts here. These are ready to go on the frame, and I think the next steps probably are just to get the braze-ons on for cable guides, water bottle bosses, the special ones I got to make for on here. I'll be lighting up the torch and getting those babies glued on.